in email, I may be using Google Mail, you might be using Office Mail, somebody else might be using Proton Mail, but we're all able to communicate with one another independent of the application that we're using because email is this underlying protocol. And Web3 and decentralized web technologies, basically, I think one kind of definition of Web3 is that everything starts to look like email, where it doesn't really matter what application you use. Like in DeFi, for example, you can trade on application A, you can interact directly with the smart contract. You're still kind of communicating with the same underlying protocol and not trapped in at that application level. And so there's one other kind of important piece to note in this definition is the thing that lets you write to these decentralized networks, of course, is a key pair, often called the wallet, that we all know, and we all kind of have a sense of what the private key is. And so let's kind of dissect that a little bit more. So, an asymmetric key pair, where you have this public and private address, basically grants somebody who controls that two powers, two abilities, two capacities. And that is the ability to encrypt and decrypt data from that key pair, as well as sign data. And so when you sign a transaction and broadcast it to a node, that's how you're communicating or sending money on a blockchain, is through this process of using this key pair to sign data, send it to a node such that it gets broadcast out, whether it's proof of stake, proof of work, various consensus mechanisms. It's from that key pair that you're able to communicate with the chain. And so that leads pretty well into what we're up to at Lit. So, as you know today, there's basically kind of two types of keys. There is a key that is self custodied. So, this is like Ledger and MetaMask. And then there's also the centralized custodial keys, which, of course, like FTX is a glaring example of why people can't pull their funds off there because of the asset mismanagement. What Lit is actually a third type of key. It is a distributed custody key. It uses a technology called threshold cryptography. And basically the kind of the easiest way to think about that is you have a number of nodes, a number of agents or parties, and each of them hold a single puzzle piece to the key. And with that puzzle piece, which is called a key share, they can sign and encrypt information. The same thing that you can do with a whole key. But the difference is this shared key where the nodes kind of have these puzzle pieces. Only when a threshold, in the case of Lit, this is 2/3, but only when a threshold of those node operators, those holders of the puzzle piece, have signed off on any given operation, only at that point can that operation of signing or encryption happen. And so, what we have done at Lit is basically built a network for decentralized, through this threshold cryptography mechanism, keys that are also programmable. So, rather than, if you think about like a centralized exchange, when it's working, basically gives you the capacity to send your tokens. Um, what we have set up on this distributed key infrastructure, where there is no centralized key master, is a mechanism for developers to write code that dictates when that distributed custody key is going
Yeah.
to
So
sign
okay.
things
So
and is
yeah,
going
thank
to
you so much
encrypt
for getting
things.
in the
And so I can jump into a
getting into
couple
it.
use cases.
First
But
thought
before I do, I
was
want to
that
see if
this
there's
it
anything I can
sounds like a
clear up
multi-sig.
on
How
that
is
little preamble
it
and
different
explanation.
from a multi-sig? I guess would be my first
Yeah.
thought.
So
And then
okay.
I
So
saw
yeah.
Ruben
Thank you
had
so much for
requested to
getting
come
in
up.
the
Um,
getting into it.
we can
First
definitely
thought
have
was
questions.
that this it sounds
We'll
like a
probably open it
multi-sig.
up for
How is
questions
it
in
different
about
from a
20
multi-sig?
minutes or
I guess
so.
would be my first
Just
thought. And
but
then I saw
if
Ruben
Ruben
had
really wants
requested
to
to
come up
come
and
up.
ask a question, I'm
Um,
happy to
uh,
have him come
we
up and
can
ask.
definitely have questions. We'll probably open it up for questions in about 20 minutes or so. Just but if
Okay, thank you
Ruben
so
really
much,
wants to
David.
come up and ask a question, I'm happy to have him come up and ask.
Sure. Yeah, we can keep it flowing, and I'll come back to the question of what is the difference between threshold cryptography and a multi-sig after Ruben's question.
Okay, thank you so much, David.
Hey team. Yeah, have to stay in the wings too if this is just disruptive to the flow. Figured it was a small room, and this is an area of intense interest for me. So it sounds like you're building really useful tools, actually, that are like generic enough to be applicable in a wide variety of scenarios, but specific enough to be sort of applied fairly with a degree of precision, right? I see you're working with ceramic too, which I'm a fan of. Um, is this? I was looking at something similar that used sort of like I want to say homomorphic keygen, where I was trying to build a protocol that would allow party A to put an asset into a decentralized environment, like a decentralized asset registry, but forced party B to get a special fancy key in order to decrypt that asset. And the only way that could be generated was to go through a sort of third party homomorphic keygen where just to mostly to avoid Sybil attacks, right? And so in this context, um, if I were to create 1,000 machines, um, would I need to be part of like a particular pool or a particular subset of users in order to be able to have the relevant keys to be able to participate in that process? Or could I sort of Sybil attack my way into, um, bypassing whatever security protocol was in place?
Yeah, good question. So lit works slightly different. So it sounds like the scenario that you presented is you have some asset. Let's say you're a creator and it's a video or an image. And this is the manner in which we're working with Lens Protocol, for example. Um, and you want to say only specific people can decrypt this content. Is that the scenario that you're pursuing?
The goal was to force the counterparty to put in the goal is trying to get around the analog loop actually, right? So this is for audio. So if I like take an MP3, right, play it on my device, put a microphone up to a speaker and record it, the computer, generally speaking, is unable to recognize the duplicate. It just sees it as a new recording, right? Um, but if there's a way so that when I force the counterparty to put their own signature um, prior to being able to interpret it, then even if they put the microphone up with a speaker, the fact on the new asset will have both signatures. It'll have the creator signature and also have the recipient signature. So that way, when somebody puts it on Pirate Bay, for example, you can't stop that from happening, but you do know that Dave put it there. Do you know what I mean? Because you got like the full provenance chain.
Yeah.
Yeah,
So I think the hard part is so it sounds like you know to my knowledge you can't like have the signature come over the audio, but once you have that audio file, you could sign that data. So those are kind of get like slightly decoupled. The way that that would work in the context of lit is let's say you had an audio file and you wanted to encrypt it such that only specific parties could decrypt it. You would generate that symmetric key. So you encrypt that audio file on your computer, and that has a data key associated with it. And then the way that lit works is it's rules based. And basically, this is where kind of like the notion of token gating comes in. Then you could say, hey, anybody who's a member of the Harmony Community DAO, or anybody who owns a Bored Ape, or anybody who has more than 10,000 ETH can decrypt this. And so let's say Alice encrypts the content, when Bob shows up later and wants to decrypt that content, he has to sign a message with his wallet. And that signed message gets broadcast to the lit nodes, which have encrypted this key and have this distributed custody going on. And each of those nodes will then read the chain and say, does this individual meet the conditions for access?
right.
And if yes, each individual node creates that authorization to decrypt. And then Bob on his computer needs to collect a threshold of those authorizations in order to decrypt that file. Now, I don't know if that's precisely the flow that you've kind of envisioned here, um, but it sounds like the other thing that you may want to pursue is having somebody that initial audio file. They potentially could like hash that file and sign it, and then if somebody else shows up with an audio file at another point, that resolves the same way, but isn't signed, then you would know that it doesn't have provenance. But it seems like what you're talking about here is more just related to signed data in general, which we can get into how lit works in that context, rather than access control, if I'm understanding the prompt correctly.
Yeah, well. So I should, to be fair, that whole part of the world, that's a different hard problem. It happens to be to stand to benefit from like decentralized infrastructure in terms of like, you know, Napster with Napster with rules. But you need to fix the audio problem, which is not a crypto. Well, it is different. It's a much older cryptography problem. It's multi-phase, multi-band, procedurally generated client-side audio steganography. I'm glad you asked. It's a fancy word for watermarks.
Right.
But yeah, it's a separate problem. What you're talking about is useful in way more scenarios, and so I'm keen to learn more.
Yeah. I mean, the best place to dive in, frankly, is just developer.libprotocol.com. That's where all the docs are. And I think this. So let me touch on the question about what differentiates this from a multi-sig, and then we can talk about a few more use cases. I think that's a really great prompt. In terms of what differentiates this from a multi-sig, is that we, as kind of mentioned in the introduction, we basically have two components. Like if we really simplify things, we have the ledger and we have the key. So a multi-sig is a smart contract that says sign this once 3 of 5 owners in this array sign off on it. This is kind of like your standard Gnosis multi-sig, also called a smart contract wallet very often. And so that's happening at the level of the chain. And that interaction is handled and mediated via smart contracts. Lit is actually more about the key. So the type of signing algorithm that you can use to communicate with EVM chains like Harmony, with Bitcoin, with Cosmos chains is a specific elliptic curve called ECDSA. And so what Lit has done is the decentralization at the level of the signing curve. And so it's from that curve that you can derive public-private key pairs for Bitcoin, for Harmony, for Ethereum, for Cosmos chains. And so you basically, like, some aspects of it are similar, especially from like a mental model perspective around like you need X of N parties to sign off on it. But the location or the setting, so to speak, of where it's taking place is different. Seeing in this MPC multi-party computation. Right? Say again?
Homomorphic encryption?
It's not homomorphic encryption. The core technology being used here is something called a distributed key generation. And that is the mechanism.
Interesting.
Yeah, so the distributed key generation is the mechanism for having a private key like not exist in its full state in its entirety, but live across these network of nodes. And then in the lit context, in addition to doing the distributed key generation, all of the nodes operations take place inside of something called a secure enclave, which is you could think of as like a black box whereby the node operators can't get to their key share, their little piece of the puzzle.
Oh my god, this is a hard problem. I was working on this. This sucks. This is a hard problem.
Yeah, it's been pretty fun. And so yeah, I think that's a great kind of enthusiasm to kind of go into really the myriad of use cases. So there's a couple hundred teams that have implemented the SDK today. Some of the core use cases that people are using this for is like token gated chat, where you say, hey, I'm writing a chat thread to Ceramic or to a system like XMTP, and only holders of this token can decrypt this. And so what's really useful here with this key provisioning service that we built with Lit is that the parties that can decrypt that content can be constantly changing and dynamic. You may not hold an NFT on day 1, but hold it on day 2, and then you can sign the message, prove that you own that NFT, and then be on your merry way with reading the chat thread. There's also this use case around kind of like gated content and intellectual property.
Do you know what you've built?
Say again?
Do you understand what you've built? Like you just built workers comp, decentralized workers comp, my guy.
Yeah, I mean you could well, say more about that. What do you have in mind there?
So I'm working on like and it'll turn into shill real quick. I get excited, so I'll keep it quick. I'm basically working on like Upwork without Upwork, right? So what does that look like? I think it's basically like instead of having like an employee management system, it's an employer management system. Like you just take the employment contract, decompile it into its component parts, give everybody drag and drop. But then that only works if they all speak to each other, right? And so at a certain point, rather than like having the DAO approach, if you can build it sort of truly interoperable and composable, what does workers' compensation look like? What does accident insurance look like? What are all these sort of financial mechanisms that we would normally rely on a third-party financial provider who takes a cut and so on?
Right.
Can you build that kind of infrastructure in a distributed environment? And if you can have shared key access for permission-based access, you've basically built a thing where the parties have to agree in order to um, distribute collected funds which might have been stored based on a previous agreement, right?
Yep.
So did this person break their leg or did they not break their leg? Well, let's take a vote. But there's no way to get around. It's not like the dumb DAO tool where like basically we're just trusting Steve. Do you know what I'm saying?
Yes, I think you'll get a kick. So totally, 100%. And so what we've just released about 5 weeks ago is the capacity to do programmatic signing. So this distributed custody key, you can basically start to think about the key itself as a place um, to develop applications. The programs, like this, just some of our internal nomenclature, we call these PKPs. It stands for programmable key pairs. There's plenty of information about that in the docs. And then the mechanism for programming the key is it's all in JavaScript. So you encode those rules, whether it's around workers comp or auth or or maybe some DeFi automation. You could use this for DeFi automation, right? Like a stop loss order on staked tokens, or like an automated liquidation prevention bot for DeFi. Encoding the rules around when this distributed custody key should sign things. And so yeah, that's the second piece of this, is this kind of programmatic signing component. A lot of the big focus today on the programmatic signing, frankly, has been on the really hard problem of crypto, which is private key abstraction. Obviously, self custody is really great for many people, and centralized custody is like quite obviously dangerous. But the distributed custody key presents an opportunity for somebody to use like Google, Discord, their Apple passkey, which is Apple's new mechanism for authorization. And yeah, I think we're getting pretty close to the day. And if this is something that's interesting to you and you want to kind of implement it and follow along, definitely hop into Discord. But getting close to the day where you generate a wallet and you associate your Apple ID. Maybe it's not like where you keep your life savings, but it's what you want to use on a day-to-day basis for interacting with the crypto world. And you take your phone and you throw it into the ocean. And then you go to the iPhone store and you buy a new phone. And because you've got this set up for the Apple auth as the authorized party that can tell the distributed custody key when to sign, you sign into iCloud, enter your PIN code, and then the device key is revived from your Apple password manager. And then it's as if you have no issue losing your phone at all. You can just kind of proceed and continue on your merry way. And so this also has, like as I mentioned, implications in DeFi. And then I'm also really excited about some of the building and discussion that's been happening around the implications for a programmable key for off-chain data. So you mentioned things like Ceramic earlier. If you think about tools like Ceramic, or there's also Polybase and Tableland, which are these decentralized databases, the nature of these systems is they have one key control a database. This is that whole kind of DID scheme. But if you have a programmable key control the database, you almost have a decentralized programmable backend that is writing data to a decentralized database. And I think we'll start to see in the future people creating applications and generating revenue on them where the application is running entirely on decentralized infrastructure. And then, Ruben, if you say, oh, you know what? I want to sell this
Mhm.
company that I've built, rather than having to go through any kind of proceedings with legal work
You have
or
food in your room?
mergers and acquisitions.
Oh.
You just sell the controlling NFT or whatever you've set up as the auth
Yeah.
mechanism to kind of sell this application. So the combination of lit is like programmatic signing
Fuck that route
and
up, man.
programmatic encryption.
I need
And
to
I have
I understand that from a
place the bait
functional
in those
perspective,
traps.
yeah.
but you're gonna have a hard time explaining that to the
Maybe,
text man, my guy.
the cage trap's big.
But I understand. I understand the fact. Um, yeah, it's
Yeah, I know what you
yeah,
mean.
4 years and the worst code base you could possibly imagine, which is law, and then reconciling that with crypto land. It's a weird environment, but yeah, I think the kinds of things that you're building here are uh, man, they're undervisible for a start, but they are incredibly powerful, and I suspect that it's things like this that are going to enable um, network stake type governance, not just in spirit but in fact. Um, and there's a lot of naysayers out there, but most of them aren't really looking under the hood.
Totally.
So yeah,
No, I really appreciate your enthusiasm. I do have to run, but I'm very very reachable on Twitter. This was super fun, and we're like actively trying to find folks in the Harmony ecosystem who are really excited about this. We have a grants program. We really like Harmony and just want to get more connected to Harmony and to the builders, because everything that we've discussed today works across Harmony, and I like it's already integrated today, and so there's a whole world of opportunity. So
Yeah, no,
definitely,
that's great. Thank you
yeah,
for
grateful to the
coming
Harmony
in,
Community
David.
DAO
And
for having
no,
me
I'm
today, and
thanks, Ruben,
um,
for stepping up.
maybe
Like
yeah, I have
super interesting
2 minutes if there's
conversation.
any
And
additional thoughts or questions,
the
but
stream
if
did
not,
work. We
this
did
was super
manage to
fun.
stream this to Twitch and YouTube.
Yeah, no,
So
that's great. Thank
yeah,
you
there's
for
going to be a
coming
recording.
in,
So if you
David.
want to,
And no,
it was
thanks,
what you guys
Ruben,
were
for
talking about was
stepping
super
up.
dense.
Like
So I know
super
I'm going to have
interesting
to listen to it
conversation.
over to kind of
And
really
the
grasp
stream
what
did
you
work.
guys
We did
were,
manage to
the
stream this to
technology
Twitch and
you
YouTube.
guys were talking
So
about.
yeah, there's going to be a
Yeah,
recording.
and
So if you want to,
so
it
hopefully we
was
can get another
what you
space
guys were
going.
talking about was
Would
super
love to
dense.
have you
So I know
again
I'm going to have
to
to
hear about
listen to it over to
developments,
kind of
and
really
yeah, we would
grasp what
love
you
to
guys were,
work
the
together more,
technology you guys were
connecting you with
talking
some
about.
builders across the space.
Yeah, and
We're
so hopefully
definitely
we can get
in
another
a
space
building phase
going.
of our own.
Would love
So
to have you again
yeah, thanks
to
again
hear
for
about
joining. Thanks,
developments,
Ruben, for
and
coming up and speaking with
yeah,
your
we would
questions.
love
And
to
have
work
a
together
awesome
more,
day. Yeah, any
connecting you
last?
with some builders
Yeah,
across the space. We're definitely in a
awesome.
building phase
Bye,
of our
guys.
own.
Thanks for
So
joining.
yeah, thanks again for joining. Thanks, Ruben, for coming up and speaking with your questions, and have a awesome day. Yeah,
Thanks
any last?
everybody. Have a
Yeah,
wonderful weekend.
awesome.